look at differential equations today. A differential equation is an equation that contains an unknown function and one or more of its derivatives. So you can see that in a couple of these examples here. This is a function, but we also see its derivatives as part of the equation too. This would be that same one written in the other derivative notation, the Leibniz notation. So you see second derivative and first derivative there. And then again, same thing here. This one's written in a different derivative notation, but all meaning the same thing for each one. The solution of a differential equation, that's a function that when substituted in, along with its derivative, satisfies the function. So if we can find a function y here, where its derivative, and we find its first and second derivatives, and we'd substitute those in to here, here, and here, and that makes this equal each other, that would be a solution. So let's try one out here. Same one we've, or a little bit different, I guess. Show that y equals e to the x is a solution of this differential equation. So one thing we're going to want to do here is find, or if we start with this equation, we need its first derivative and its second derivative here because those are part of the differential equation just like y is. So what are the first and second derivatives? Well, this is an easy one. Each derivative here is going to be e to the x. So now what we're going to do is substitute those into this differential equation and show that both sides are in fact equal here. So our second derivative, that's e to the x plus 2. Our first derivative is also e to the x equals 3, and y is e to the x. So if we simplify this, the right side just 3e to the x. On the other side, we got 1e to the x plus 2 to the e to the x, which is 3e to the x. And both sides are equal, so that shows that e to the y equals e to the x is in fact a solution of this differential equation. Let's have you try one. So same differential equation, different solution though. They want you to show that this function is also a solution to the same differential equation. So why don't you pause the video, see if you can find those derivatives and show that both sides are equal. All right, hopefully you've got it here. So first derivative, make sure you use chain rule here. You're going to get same exponential, and then derivative, the inside part would be -3. Chain rule on the second one again, so -3 times -3 would be +9. Now substitute those in. So here's our second derivative. We substituted in. Our first derivative we substituted in. Y we substituted in. Simplifying then, you should get that both sides are in fact the same here. So not only is y equals e to the x a solution like we saw, also y equals e to the -3x is a solution. So differential equations can have more than one solution function to them.